Welcome to another GCBASIC demonstration. This is a suite of videos for the legacy 16F, could be 10F, 12F chips. I'm doing a set of videos for legacy chips so that people don't get confused around some of the advanced capabilities of what we call the newer chips. Okay, let's get into it. So we're going to make some LEDs flash. Um, they might be in sequence. We'll go through three programs to see how we can make some LEDs flash. Quite cool. Like and subscribe. That is like really, if you don't do that, the numbers just don't work for me. And watch the video all the way through. Just let it run in the background. Listen to my dulcet tones. Okay, so we're going to make 4 LEDs flash. Um, we won't be doing the sequence today. We'll do that tomorrow in another video. We'll see if we can get to it today. Let's get started. So GCBASIC open source compiler. That means that it's published on the internet. You can change the source and have a look to see how it works. It supports the 16F chip family, and it has done from the outset. So I'm assuming you've installed the GCBASIC software. You've downloaded that from somewhere. You've installed your programming software. You tested that the 16F works, and you've got tutorial 1 being completed. So I've got a camera here. I should turn the light off really. It's over the back. Let me just turn that off. You can see the LEDs working there. Where's that switch gone? Here we go. Look, turn that off. That's where we left it. That's the power LED, and we got 4 LEDs in a row here, and we're going to make those work. And I'll have to keep leaning across the back to make this thing work. This is the board I'm using. It's a board, as you just saw in the camera. It's a 2010 demo board. It works fantastic. 16 British pounds from eBay. Well worth the investment. This has got so much capabilities, and that you can learn an awful lot from this type of board. I know I'm pushing the price up on eBay, but if someone's got one of these tucked away, put it on eBay, let someone else have it, okay? So what we're going to do is we're going to make some LEDs flash. My LEDs are on port B, and this little diagram, we'll see this in my source code. So I've got a prototype board, some electricity, 5 volts, a programmer, PIC2, and some LEDs and resistors. There's lots of other things on this board, but that's what we're focusing on in this video. So what we're going to do is we're going to do some LED flashing. Okay, we're going to initialize the board. We're going to set the LEDs, have a delay, unset the LEDs, delay, loop. It's a very simple process, and it's simply done in GCBASIC. There's very, very little to be done to make this work. So we're going to flash the LEDs with a delay. I'll explain some of that to you. Simple logic, and we're going to use a register called port B because that's where our LEDs are attached. We'll use other commands as we move through the demonstration. So let's get into the workshop and get our hands dirty. So I have opened up. Have I opened up? I don't think so. Let me open up the GCStudio. So hit the Windows key. GCS will bring up GCStudio at the top. We'll zoom in so that you can see that. Let me have a look. There we go. I'll just do it again now. GCStudio. Oh, my screen's in the wrong place. I'll just do it for the 3rd time. GCStudio. There it is. I hit enter, and it will take you through to the this screen, which is the dialog for GCStudio. And in here, you can get to a lot more tools. You can, for instance, in the spanner at the top here, if you go into there, let me just get into there because it's actually tucked behind my camera. You've got a lot of other settings, and we'll come into those settings later on. Press the back button, and in we go. So let's open up our folder. Our folder has all our source code in it, and it's in this list here, and it happens to be my 3rd one down, and it's actually called PICdem something, and it just disappeared because it's opened here. It's the PICdem2 plus board underscore 2010. There's a load of demos in there, okay, and we're going to look at those demos. Here is the IDE that's open. This is called GC code. So whenever you see this type of layout, that's the editor, the IDE, and it has access to many different tools. And if you want to have a look around those tools, press function key F4. When you're in function key F4, you will get a list of all the different things you can do. And that's why it's called an integrated development environment, because it lets you into all these different tools. They're all in this menu, function key F4. So what we need to do is open up the Explorer, and you can do that by, and I will zoom in so that you can see the top right-hand corner. I can click on this Explorer and it will list the files in this folder. Click, it opens it up and it lists all the files. Now, as you go through the compilation, you may end up with more files in there. All the compilation files end up in this folder. But you can filter in here by pressing Control F, and it says type in a search GCB, and it highlights all the GCBs. And then there's a little filter icon here, which is like a little upside down triangle with lines. Click on that, and now it's only going to show you source files.gcb, and that is the source file extension that we use. So previous video we used number 10, hello world. We're going to select blink. Control B to get rid of that. Now, I've got some color on there. Let's go through from the top and we'll see what's happening. Well, first of all, my tab is set incorrectly. So I'm just going to change my tab by pressing function key F4, type in the word tab size, tab, just type in tab, change tab size, and it will just set the tab for me, okay? And the tab wasn't set properly. Now, hash chip, that's the chip I'm using, hash chip 16F1937. That's what we're using, so we just put that in. The frequency will always be the fastest frequency, and we'll look at other frequencies later. Option explicit, I explained, always put that in your program. That ensures that you define your variables. This is a diagram I use for documenting my code. I'm using port B, I have 4 LEDs on it. Just so you know, I also have an LCD, and this is all the documentation for the LCD, but we're not using that in this program, so I'm going to take that out and to get rid of it because I'm not using it. It doesn't clutter my program. I can see from this little diagram that I've made by hand that there are 4 LEDs on port B and there's nothing else. I had a program sent to me last week that was not working, and the person had got all confused on their port addressing, and all it was is they hadn't documented what they were doing. After a small tweak and make this diagram for them, I was able to show them that they had 4 things all happening on the same port. Right. Anything in green is a comment. This is the whole program. This says port B, set that direction of port B to be an output. DIR is direction. It's in blue. Port B is a constant for the port, the whole port, 8 bits of a port, and I'm setting them all to an output. And then I've got this wonderful thing which is called a do loop, and you can see that do loop here. It's actually got a little line joining it together, and in the other legacy IDE that we've got, you'll also see these lines, and they help you visualize what's going on. I'm going to set the LEDs to all the LEDs to on, and so I would set that to a bit value of 255. Let me just show you how I get that bit value. If I open up a calculator, an old calculator, the old classic calculator, like this, view, if I view that and put it into programmer mode, if I wanted to set all 8 bits in here to a value, if I put this into binary mode, look, I can click on here and I can click on the 8 bits of a value of a byte and then go decimal. The value is 255. I am not going to explain how hexadecimal works. I'm going to assume you've got some insight into that. So I'm setting all 8 bits. I'm going to use an internal instruction called wait for milliseconds. If you press function key F1, it will open up the help. And it will tell you the syntax for wait. And it says wait, a time, and a unit. And those units can be microseconds, 10 microseconds, milliseconds, 10 milliseconds, minutes, seconds, sorry, minutes, and hours. And all that is calculated automatically for you. There is no other bottom end. There's no more. There's no other thing else required. You just say wait 500 milliseconds, and it will wait 500 milliseconds. And it's based upon the frequency of the chip. And it's not guessing it. It's running it at the fastest frequency. If you change the frequency, wait is recalculated in the background for you. Now we're going to set the LEDs off by setting it to 0 and wait another 500 seconds, loop back and do the whole thing again and again and again. So let's look at what I'm calling, I always nickname this Zen mode. We can see what's happening here. And I'm going to press on this, in my programmer, I'm going to press function key F4. And it has a little drop down menu, and I'm going to select make hex and flash function key. It's the same as pressing function key F5. The dialog window jumps up at the bottom and it passes it out to the programming software. The programming software then moves the software, your newly created hexadecimal file, and puts it inside of the microcontroller. The microcontroller then goes through the initialization process. It then sets the port to an output, and you can see, even without turning the lights off, which I'm going to have to do, the LED is flashing every 500 milliseconds. I don't even have to check that. I'm very confident that is working. And so there's no ambiguity around this, as in with C, it will work for you. To get rid of the dialog box at the bottom, press Ctrl J. Is the quickest way. Let's have a look at another demo. Ctrl B to open up the Explorer, my quickest way. Take 30, 30, blink another way. Well, let's have a look at the top of the program. It's exactly the same. Hash chip, then specification of the chip, option explicit, same diagram. I will just take this out because it just annoys me. That isn't the LCD. We're not using the LCD. And now I'm going to use what's called some constants. Control B to get rid of that window. And let's zoom in on what we're doing. Here we go. So now I'm going to introduce another concept, and they're called constants. A constant is something that enables you to define it once, reuse it many times in your programs, and that means that when you change the constant, all those changes are reflected throughout your program. It always use a constant. It just makes things so much easier. Hash define. That defines a constant. It makes things easier for you. And I have said LED 0 is on port B.0, LED 1 is on port B.1, 2 and 3 on port B.3. Now, you will see me develop these constants as we go through. And I then say, rather than the port address, I say direction, which we saw before in the previous demonstration. DIR, LED 0 is an output. LED 1, same, 2 and 3. We're using the constant. This is useful. Investigate that on your own. So in our main program, I'm going to flash one LED for 1 second. Wait 1,000 milliseconds. Flash LED. Not LED flash. Where does it say flash? It doesn't say that at all, actually. But it says LED 1 equals not. This is a not. Maybe we should not LED 1, and that will toggle the LED on and off. Function key F5 to program it. Let's look at this mode, Zen mode. All 4 were still flashing from the previous. And now you can see that one LED is flashing, and I can change that LED. I'll just turn the light off. So I can control it through a constant, and I'm addressing one particular port, which is LED 1, was it? It was LED 1. Let me Control J, LED 1. So we've got a lot of control that we can actually make. Let's have a look at, let's get excited here. Control B, open it up, open up the Explorer. Blink another way, or is it rotate? Let's look at rotate. 0, that's number 40. I've just double clicked it and to open it up. I'm going to press Control B to get rid of that. And then I've got the program on the screen. Let's have a look. You're going to get bored by some of this stuff because I am pretty consistent about this. Hash chip, that's the chip we're using. There's my little diagram. You've seen that before. I will correct it because I will publish these later on. I'm going to make sure they're okay. The same constants are shown, exactly the same constants. But this time we're going to do some heavy maths. Ha! It's not really. The brown stuff here, this brown stuff just means that the indent is a little bit confused. So the indent on my default computer is clearly function key F2, change tab size, default tab, and then I think that will fix it here. Oh, there you go, that gets rid of it. The colors just indicate that the tabbing isn't correct. There might be a white space in it. So what we've got here, let's look at the main loop to start with, and then we'll see. Do main loop, just do it forever. It's going to rotate something. Let's program it, have some fun. Function key F5. Let's see what it's going to do. Then we can see. Let me turn the light off. I'm going to get sick of turning this light off. Look, it's doing something. It's rotating the LEDs. It's pushing them to the right. It's set the first one, second, third, and fourth, then going back to the beginning. It's rotating. That's called rotation. It's just, I'll put the LED. You can sort of see that in the background. Let's explain how that works. Control J to get rid of the programming window or the terminal window. And when you have bugs in there, you'll see that terminal window a bit more often. So how are we doing this? Well, if we look at them at how we initialize it, we define a variable. Whoa, a variable, okay? A variable called LEDs. It's a arbitrary name, could be called my left foot, as a byte. And that means it holds a value of 0 to 255. And I've said the first thing I want to do is set LEDs to a binary value of 0001, which for those uninitiated means 1. So I'm going to set set that value, and I'm going to push that into port B, which we've seen that port B can be set directly. And then we're going to do some rotation counting here. We're going to rotate we're just going to have a variable that is how many times we've actually set or used the commands. So I was going to set that to 0. Okay, the first thing we do inside our main loop is set the port B to the value of LEDs. Well, that was already set to 1 initially. Then look at this. Rotate the variable called LEDs to the left. That means it actually means multiply it by 2. But it's a low-level instruction inside the microcontroller that says move it to the left. And simple means don't carry. And we'll look at carry later on, just for the time being, except simple. It means don't carry the value that's in the carry register inside the microcontroller. Once we've done one rotate to the left, then we're just going to increment rotate counter, the rotate count variable. It's a byte variable. And it says if the rotate value is greater than 4, then reset it back to number 1, and then reset the rotate counter. So what's going on? It waits for 100 milliseconds. But magic's happening because we're going to go back and we're going to set LEDs back to port. Well, we've rotated the LED value by 1. It's rotated it once to the left. So what was number 1 is now number 2. The next time through, what was 2 becomes number 4, and what was 4 becomes 8. And when it goes more than 8, it gets back to number 1. So you've got great control using a few variables, some low-level commands, which is actually the rotate command, but it's all built into the compiler. And we can see later on in assembly how that all works. But for now, we're going to call that enough. So we've learned quite a lot. We've learned how to use a variable, how to use rotate, and a bit of logic. Look at this logic. If rotate is greater or equals than 4, then do something. So these are the structures that are supported. You've seen the do loop. That's essentially a very simple loop. Do it forever. And if you've noticed, things are not case sensitive. And you can assign constants to things like port B is a constant. We've created our own constants as well in the previous video. But we'll leave it at that for time being. So what we're going to do now is on the next video, we are going to set the LEDs to represent the value of an ADC. That is a analog to digital converter. So we are moving through at pace. We've got these LEDs rotating, but why don't we control the speed of that using the value from the ADC, and it will introduce a whole other concepts as well. Enjoy.